you're ready.
All right. Well, as a topic today, I chose to talk about cathodic protection. Anybody here from an oil field background or know somebody that works in the oil fields? Yeah? Does anybody know anything about the oil field at all? Okay, one person, two people. So, what is cathodic protection? That long definition there, which I'll shorten it. Cathodic protection is a technique of pipeline protection, specifically focusing on steel flow lines. We use the potential of metals to reverse the corrosion process of the steel flow lines that are in the ground. Anybody know what kind of other flow lines that are put in the ground at all? No? Okay. There are three kinds of flow lines. Most of the oil companies like to use poly or plastic flow lines nowadays. Steel flow lines that were put in the ground 35 years ago are protected by the process that my company and my family has done for generations. Now, when going into pipe or cathodic protection or any oil field job, there's a few requirements that you have to have. One, coveralls, as you can see. You need to be fire protected. Steel toe boots, hard hat, like any construction job. But another thing is that special tool there, known as a forehead monitor. That monitor is your lifeline out in the oil patch. If you do not have that monitor, you're probably going to die. It protects you from a segment of gases, most importantly, which is known as H2S, dihydrogen sulfide acid, which in high concentrations can knock you out in about 6 seconds. Most of the fields around Medicine Hat and this area are pretty safe. They're known as sweet sites. There's low to no H2S. You can be safe on there. A lot of people get away without wearing the monitor, which in my eyes, they are retarded. In many, many ways, because a lot of people there's been a lot of incidents out where I used to live in Lloyd that are high concentration where people have died, and that's why we have the safety regulations and every rule in place out in the oil patch. Few other requirements that I personally have to have when working out there. I need a couple of, every oil field worker is required your first aid tickets. So your first aid, AED, and CPR. The H2S course that you need to take in order to learn how to use your monitors and air masks if required. Transportation of dangerous goods, and ground disturbance level 1. With what I do, we do a lot of digging, so in order for me to be a part of any of those projects, I have to have these safety tickets or I can get really big fines. And then, as well as whatever company you work for, you need to have your oil field orientation for that company. It's really basic and really annoying to take. And if you're working in Alberta for cathodic protection, you need to have a course known as your cathodic protection level 1, which is just the basics of cathodic protection, which I'm about going to try to wrap up here in about the next 8 minutes. So, like I said, cathodic protection is the process protecting flow lines through the potential of metals. So, what we do is we hook up an anode or cathode or however you want to call it, something like this, to your flow lines. That being a cast iron anode, we use that on an impress system, which I'll get to in a bit. To make it simpler, the magnesium anodes go on a sacrificial system. Essentially what we do is we hook it up to a flow line, and because that magnesium anode has a higher potential than the steel flow line, that will corrode and protect the flow line through an electrochemical process, which is rather complicated and really, really hard to explain. So these are some of the tools that I use when taking readings. In order to know that your flow lines are protected, you have to take readings down the line. When you're looking at your readings, you want to see numbers between 1200 and negative 850, which those numbers mean 1200 is, well, the anode is on, negative 850 while the anode is off, and that off reading tells you if it's protected due to the flow of the current that the potential of metals makes. So how do we get these on-off readings? We use a tool called an interrupter, and we got some fancy GPS-looking new ones like that, smart interrupters. We hook them up to a rectifier, or if it's a sacrificial bed, just directly to the anode wire that comes up to the flow line itself. And it'll, through a GPS satellite device they use, it synchronizes to your other one if you need it, and you can get your on-off readings. It'll switch, like turn off your current or turn on your current in a matter of seconds. Use the voltmeter so to take my readings and the amp meter on a rectifier, which I'll get to here in a minute. There's a list of potential of metals. Steel is not on here, but steel is a form of iron. You can see how iron is down here and magnesium is above it. Magnesium having a higher potential than iron, just a little illustration. Here's the diagram of what an impressed system looks like. So here's your flow line, here's your anodes, and here is a device we call a rectifier, which I mentioned here a few seconds ago. This rectifier controls the amount of amps that goes from the flow line to the anodes. On a sacrificial system, when we use our magnesium anodes, magnesium anodes only have about a 1 amp push, and you can't really control it. When we put magnesium anodes, we just drop it into the ground, hook it up to the flow line, and that's it. The impress system, depending on how big your flow line system is, you can control the amount of amps that go through that system, through that rectifier. And rectifiers come in a matter of a large number of sizes, depending on what your flow line system looks like. Now, when I say we put anodes into the ground, the process of protecting it, you need three things, kind of like a car battery. You need your positive, you need your negative, and you need an acid to make that process work. So the positive, so to speak, is the anode, the negative is the flow line, and the acid is the ground around it. The ground around the anodes did my main system work? I'm not entirely sure where I was going with that now. Okay. Next point I want to get to is, why is it important? Does anybody want to take a guess on why protecting the metal flow lines in the ground is important?
Pollution.
Yeah, exactly. With metal flow lines in the ground likes to react with it and corrode it, and if you don't have any protection on it, you're going to have line breaks all down the line, and your farmers and whatever flow line goes under, everyone's going to be very, very mad at you. Oil field companies do get in a lot of trouble because cathodic protection is one of the last things companies like to think about because of the cost that it takes to put these systems in. So if you're doing, one of the jobs that I worked on this summer, for the cost-wise was about $1 million to put what I'm going to consider a small system in. Only covered about 10 miles of line. We put in 8 cast iron anodes about 200 feet down over in an area called Esther. Everyone knows where that is. Just did a replacement bed, replaced it. One of these systems can last about, if done right, can last about 25 years. $1 million for a 25-year investment to protect your flow line, that seems pretty good, speaking oil field wise. Yeah. What else do we got? No, that's it. That's as much as I could say in about 10 minutes. If anyone wants to get more technical or have any other questions, feel free to talk to me later on.